Hey guys, welcome to Homework Help for Year 7, Term 3, Week 4. On page 23, we're doing the topic review. Question 1. Sketch each of these parts of a circle. Okay, so we have a circle, and we have the center, somewhere around there. A. Diameter. Diameter is just a line that goes from one part of a circle to the other part and passes through the center. That's diameter. B. An arc. An arc is just part of a circle. So imagine if I have from here and here. So that's an arc. Okay. Next one, a segment. A segment is just, if you were to cut this circle, let's say like this, this can be considered your segment. Something like that. That's a segment. A sector. A sector is if you were to, let's say, cut part of a circle that looks like a pizza shape. So this shape here is called a sector. A tangent. Tangent is just a line that goes on the outside, and it just touches the part of the circle at one point. That's a tangent. A chord. Okay, a chord is a line. I'm just going to do it in black. It's just a line that, let me see, I'll use it on this side. There's a chord. It's just a line that goes from one circumference of a circle to the other one, and it doesn't pass through the center. If it passes through the center, that's also a chord, but that's called a diameter. So that's that one. Radius. Radius is just half of so this is the radius, half of diameter. And a semicircle, obviously a semicircle is just half a circle. Alright, next one. Draw a diagram to show a chord that is perpendicular to a diameter but parallel to a tangent. So we have to know what each part is, and we can draw the circle. So here's a circle, and it says draw a diagram to show a chord. So let's draw a chord. So I'm just going to do this. There's your chord. So chord that is perpendicular to a diameter. So alright, so I'm going to draw a diameter. Imagine that's the center there, and this is your diameter. Oops. Alright, center's over there. Now these two are parallel. It says parallel to diameter, but alright, perpendicular to diameter. Whoops. Okay. So that means I drew the chord wrong. The chord has to be parallel to diameter. So it should be like this, but perpendicular to diameter and parallel to a tangent. So imagine this is a tangent. There you go. So it's perpendicular to the diameter but parallel to the tangent. There's your answer there. Alright. Question 3. A circle has a radius of 9 centimeters. What is the length of the largest chord? Now the largest chord is diameter. The largest chord of a circle is your diameter. So you can figure out what the answer to that one is. Question 4. What fraction of a circle is each sector? To find the fraction of the circle, we just put the angle over the whole of the whole amount of a circle, and the whole amount of a circle is always 360. So we'll do 100 over 360. Simplify that, cross out the zeros, you get 10 over 36, and simplify that, you get 5 over, what is this, 18. So 5/18. A fraction, there's your fraction. You can do the same thing for this one. Question 5. A chord PQ has length 12 centimeters and is 8 centimeters from O. From what? So, okay, let me try that. The center of the circle. Alright, so let's draw that real quick. Has length 12 centimeters. Chord. So this chord is 12 centimeters and is 8 centimeters away from the center. So that's 8 there. Find the length of the diameter. Okay, to find the diameter, we need to find the radius. And let's say, so I'm going to redraw this. So this chord is 12 centimeters and the length of this chord from the center is 8 centimeters. That's what it says. The center of the circle. Find the length of the diameter. Alright, so to find diameter, we're going to find the radius. So here is the radius. So we'll call it R. And you can see that we have a right angle triangle here. Okay. Where this is 8. And this side is half of the chord, which is 6. So you got a right angle triangle with 6 and 8. So this one, using Pythagoras, we can find out that this one is going to be 10. Because 6 squared plus 8 squared is equal to 10 squared. And if radius is equal to 10, that means diameter is double of radius. So that means diameter. So diameter is equal to 2 times 10, 20. Right. Next question. Find the area of the triangle POQ. Okay, this is the O, the center O. PQ, so P and Q. We need to find this area of this triangle here. I'll put this in blue. There we go. Now, imagine there's your triangle. So we know this, it has a base of 12. Okay. It has a height of 8. How do you find the area of a triangle with base 12 and height 8? Well, area is equal to a half times base times perpendicular height, which is a half times by 12 times by 8. And work it out the answer there. Question 6. Find correct to 1 decimal place the circumference of a circle with radius 15 centimeters. To find the circumference is like finding the perimeter of a circle. And remember that the circumference C is equal to 2 pi times r. Or you could say that's the same as diameter times by pi. Because 2r is just diameter. Alright, so it has a radius of 15, so we're going to use 2 times 15 is 30, so it'll be 30 pi. Now the radius is 17.5. 2 times 17.5 is going to give you 35, so 35 times pi. Remember, diameter times pi. Once we find the diameter, we just multiply by pi, and that's the answer. Now this one is diameter is 12, so this is 12 pi. This diameter is 8.6, so 8.6 pi. Now this is just the exact value. They want it to 1 decimal place, so use your calculator and work out what each of these answers are. Question 7. Find the total perimeter of each sector. Correct to 1 decimal place. Okay, so we want to find the perimeter, so we need to find, first we find this part here. Let's do that. This is half of a circle, semicircle, okay. So to find the perimeter of the semicircle, we find the perimeter of the whole circle divided by 2. So the circumference of the whole circle is going to equal to diameter times pi, and then we have to divide it by 2. And that's going to give you, so the diameter is 18, 18 times pi divided by 2, that gives me 9 pi. So this whole part here is 9 pi. Now we have to add that 9 pi with 18, because we got that piece at the bottom, 18. Okay, so that's your exact value. Now they want it to 1 decimal place, so give it to 1 decimal place using a calculator. Now question B, we're going to find the... Actually, I'll do this in blue. We're going to find the perimeter here and we're going to do quarter circle. So circumference of this quarter circle is going to be diameter times pi, or we can do 2 times radius times pi. Now radius is 5, so we say 2 times 5 is 10. So circumference is equal to 10 pi, and that's the whole circle. But we only want quarter of a circle, so we divide it by 4. And let's simplify this. 4 and 10, I can do 2 and 5. So that's going to be 5 pi on 2. That's the circumference of this quarter circle. Then you have to add with this length. You have to add with this length here, which is 5, plus with another 5. So that's going to be 5 pi over 2 plus with 10. This is the exact value of the circumference. Of the perimeter, sorry, not the circumference. Now, you want to one decimal place, use a calculator and figure it out. Question 8. Find the total perimeter of each figure. To find the perimeter of this, we're gonna, you see how this is half a circle and this is half a circle. If I take that, oops. If I take this and I combine it with this, I get a full circle, right? So what I'm going to do is I'm going to take that full circle and I'm going to add it with this and this. So that means we just find the circumference of this full circle. Now we know the diameter of this circle is 30. They both have the same diameter. So that's why that's why we can combine these two half circles to make a full circle. When I add, so first I have to do 50 plus another 50 down here. That makes 100. Okay. Then I'm going to add half a circle and half a circle, which is like adding a whole circle. Okay. So we add the whole circle. Now this diameter is 30. So the circumference is 30 times by pi, because it's diameter times pi, which is 30 pi. So circumference of this full circle is 30 pi. We got the two lengths here and here, that's 100. So we add it together. Is 100 plus 30 pi. Again, this is the exact value. Find the decimal equivalence using a calculator. Done. Alright. Question B. We're gonna add we'll ask to find the perimeter of this, so we're gonna find the circumference of this semicircle. Now this semicircle has a diameter of 10 centimeters. So circumference of this is gonna equal to 10 times by pi, and then we divide it by 2 because it's a semicircle. And that's going to give you 5 pi. Leave it like that for now. And then we're going to have to add with, what's this? Okay, first we know this is 10, so we're going to add with 10. Then we're going to add with this one. Now, imagine if that's 10, then the radius must be 5, right? The radius is going to be 5. That means from here to here must be 5. Just like it is from here to here. And that's 5, then this must also be 5 as well, because that's also the radius. So we're going to add 5 and 5. So so the perimeter is equal to 5 pi plus 10 plus 5 plus 5 is equal to 5 pi plus 20. And then use your calculator to find out what the rest is. I'll put it over here. Alright, next one. Now you have a quarter of a circle. So that's a quarter of a circle there. And I'm going to draw the imaginary radius to this circle. Now we know that this, we need to find the radius. Okay, we know that this is 14, and we know that this is 11. So what's the missing piece? So we do 14, take away 11, that gives me the radius is equal to 3. So the radius is now 3. This is 3. So what we're gonna do is we're gonna find the circumference of this quarter circle, radius 3. Alright, so to find this circumference of this quarter circle, we do 1/4 times 1/4 of 2 pi r, or we could say 1/4. Now if the radius is 3, radius equals to 3, diameter diameter must equal to 6. So we can say 6 times pi is the full circle, and then we multiply by 1/4, or we divide this by 4, same thing. Now simplify that, we're going to get, this will be 2, this will be 3, so 3 pi on 2. So that's the circumference of this quarter circle. Now, so we have to, so the perimeter is going to be that piece plus 11, that's 11 there, plus that piece, plus 3, plus 14. And that's going to give you 3 pi on 2, plus with, now 11 plus 3 is 14, 14 plus 14 is 28. And there's your exact value for the perimeter. Again, calculator to get the decimal equivalents. Next one. Excuse me. Alright, what we're going to do is we're going to find the circumference of this semicircle. Okay. Now this one is going to be, let me just draw it a bit better. There we go. I'm going to do this one, and this is, we have diameter, which is 24. So the circumference, I'm going to call this C1, is going to equal to diameter times pi, remember, diameter times pi, circumference, and that's equal to 24 pi. But we only have half a circle, so we have to divide it by 2. And that's going to give us 12 pi. There you go. Looks a bit messy, but there. Alright, now I want to find the circumference of this smaller semicircle. Okay, so this smaller semicircle, if this is 24, then half of it must be 12. So this must be 12 for the diameter. So to find the diameter, the circumference of this semicircle, we'll call this C2. This will be C3. Okay, or actually, I'll call this C2 as well, because they're both the same. These two are the same. You can see it in the diagram. Now, so let's find the area of, actually we have to add, so to find the perimeter, we have to add C1 plus with C2 plus C2. Now C2 plus C2 is just half of a circle, and the other C2 is another half. So if you add it together, you get a full circle. Okay. So let's find the circumference of a full circle. Right. Let me just show you. Okay. So the circumference is equal to diameter times pi, which is 12 pi. We're not going to divide it by 2 because we got 2 of these. So that means C2 plus C2 is going to be 12 pi. So the perimeter is going to be 12 pi, the top one, plus with the bottom one, which is 12 pi, and that gives me 24 pi. Okay, now that's the exact value. Find the the decimal equivalents to 1 decimal place. Question 9. The diameter of the Earth is approximately 12,800 kilometers. Calculate the distance around the Earth at the equator correct to the nearest kilometers. So I might have to rub out some of this stuff. There's no room here. Okay, so we have the Earth, and it has a diameter, that's the center, has a diameter of 12,800 kilometers. Now, we want to calculate the distance around the Earth. This is another way to say circumference. So you want to find the circumference, you're going to do diameter times it by pi, or you could say 12,800 times pi. And it says to nearest kilometer. So use your calculator, work out what this is, and it'll be in kilometers. Question 10. Find correct to 1 decimal place the radius of a circle with a circumference. Alright, so you're given the radius and you're given circumference. The radius is equal to actually you asked to find the radius. The circumference is equal to, remember, 2 times pi times r. Whoops, let me just do that again. 2 pi r, and that's equal to 48.5. So to find r, okay, let's look at this real quick. So let me rewrite this. 2 times pi times r is equal to 48.5. To find r, we must divide both sides by 2 pi. So r is equal to 48.5 divided by 2 pi. And use your calculator and you'll get the answer for the radius there. We're working backwards. The diameter of a circle is it says the diameter of a circle with a circumference of 120. So question B, you're given the circle, and we asked to find the diameter. So find the diameter. Now we know that circumference is equal to diameter times pi, and that is 120 centimeters given to us here. So diameter times pi is equal to 120. How do we find the diameter? Well, we divide both sides by pi. So diameter is equal to 120 divided by pi. Just use your calculator and work out what that is. Question 11. Find correct to 1 decimal place the area of a circle with radius 9 centimeters. Okay, to find the area of a circle is given by the formula area equals to pi times radius squared. So we know if we're given the radius, we can just plug this straight into the formula and say, okay, well that's pi times 3 squared. 3 squared is 9, so that's 9 times pi. Put it into the calculator, get your answer to 1 decimal place. So you're given the radius. Now this one, question C, you're given the diameter. So for the area, we need to have the radius, not diameter. So change it to radius. If diameter is 16, then the radius must be half of 16, and that's equal to 8. And then just again plug that into the formula. Area equals to pi times 8 squared. And that'll be, so that's equal to 64 pi. Put it into the calculator, get the answer. Again, do that same thing with question D. Question 12. Find the area of each figure correct to 1 decimal place. The area of this semicircle is just the area of a circle divided by 2. So the area is equal to a half times pi times radius squared. Or think of it like this way. it'll be pi times r squared. This gives the area of the full circle. Okay, I'm gonna call, and to find the area of this semicircle, which is divided by 2. So it'll be pi times, what's the radius? The radius is half of 19. So that'll be 9.5 squared. There you go, and use a calculator and get the answer correct to 1 decimal place. Now this one is quarter circle, so we say area is equal to pi times r squared, and we divide it by 4 because it's a quarter. And that's going to be pi times r is the radius is 13 squared divided by 4, because you can see here this is the radius and that's 13. Alright, put that into the calculator and see what you get. Next page. Question 13. Find the total area of each figure correct to 1 decimal place. Okay. To find the area of this strange shape, we're going to find the area of this quarter circle. But to find the area of this quarter circle, we need to find the radius. Now we know that this is the same as this. Okay, from the looks of it, you can see that it's the same because this is a parallelogram. Oops. So if this is 17, this must also be 17, and this is 17. So the radius of this quarter circle is 17 centimeters. So to find the area of this quarter circle, we just do this is pi times radius squared divided by 4. And that's going to be pi times, what's the radius? 17 squared divided by 4. Okay, let me just do that real quick on the calculator. So 17 squared is 289. So 289 times it by pi divided by 4. And that's going to give you 72.25 pi. Okay, I left it in exact form. So the area of this is this much. 72.25 times pi. Now, the area of this parallelogram is going to be the base times the perpendicular height. Okay, so the base we know is 26. So the area here, I'm going to do it in blue actually. So it'll be 26 times by the perpendicular height, which is 15. And that's going to give you 390. So the area of the entire thing, area total, is going to be this amount plus this amount. So 72.25 pi plus with 390. And then you can, so this is the exact area, and now you put it into the calculator and you'll get your 1 decimal place value. Put all that into the calculator. Now question B. To find the area of this shape, let me just rub some of this out. Looks okay. Whoop, no. Alright. Now we're gonna find the area of this rectangle, which is really easy. We got 10, whoops, that looks horrible. This is 10, and this one we need to find the width of this, or the height of this rectangle. Now let me see. We know that this is also 10. This is 10 as well. This is also the diameter of the semicircle at the bottom, which means the radius must be 5. Okay, so the radius is 5, so this must also be 5. Okay, so we have that this whole thing is 13. But then this part at the bottom is 5, so this is 5. So 13 take away 5 and that will give you 8. So this upper part must be 8. Okay, so which means that this length here is 8. So now it's easy to find the area of the rectangle. So all we got to do is just say 8 times 10, that's 80. That's the area of that one. And now to find the area of the semicircle at the bottom, we know the radius, we know the radius is 5, so the area is equal to pi r squared, which means pi times radius squared. Radius is 5, so 5 squared. So this is 5 squared is 25, so this is equal to 25 pi. So the area of the top is 80, the area of bottom is 25 pi, so the total area of them two, area total, is going to equal to 80 plus 25 pi. This is the exact area. Now, if you want to find to one decimal place, just plug it into your calculator. I'm not going to do that for you, you can do that there. Question 14, find the shaded area in each figure. Alright, you're going to find the area of the big circle minus the small circle. So, area total equals to area of the big one, big circle, minus the area of the small circle. You can do that yourself. You're given everything there. Okay, so I'll show you. You're given the diameter of the big circle, which means the radius of the big circle must be half of that. So if that's 8, this must be 9. And the radius of the small circle, we got the diameter of the small circle is 8, so the radius must be 4. Okay. Question B. You're going to do this one yourself. Question B, I'm going to find the area of the semicircle, take away the area of the triangle. So area total, or actually I'll just say the area of the shaded, not total, shaded. Is equal to the area of the circle, semicircle, take away the area of the triangle. You can find that yourself. Question 15. For each figure, find the value of x using Pythagoras theorem. Okay. Well, we have a right angle triangle right here. This is 36. This is 39. So we got this is, imagine this is A, this is B, and this is C. Remember that A squared plus B squared is equal to C squared. This is Pythagoras theorem. We don't know what A squared is, so we leave it as A squared. B squared is 36 squared. So plus with 36 squared equals C squared, which is 39 squared. So to find A squared, we're going to do 39 squared take away 36 squared. Okay, all I did was I took away 36 squared to both sides. Okay, so A squared is equal to 39 squared take away 36 squared. Now let me do that real quick on the calculator. 39 squared take away 36 squared. And that's A squared is equal to 225. So A is equal to the square root of 225, and that'll give you 15. Alright, next question. Question B. We're going to find x. Okay. So here we have this length here is the radius of this quarter circle, which is 30, which means that this must also be 30 because they're both the same length. So you have a triangle like this, and this is a right angle triangle, so we can use Pythagoras. Remember, Pythagoras only works for right angle triangles. So we have 30 x squared plus 30 squared is equal to 34 squared. So what we're going to do is we're going to take away 30 squared to both sides. So you're left with x squared is equal to 34 squared take away 30 squared. And then to find x, we have to do the square root of whatever answer we get there. So I'm just going to do this real quick. 34 squared take away 30 squared is equal to 256. Do a square root of that, and you're going to get 16. So x equal to 16. Now, in these two cases, the answer is a whole number, but it's not always a whole number. Okay. Question 16. A flat circular plate of radius 5 centimeters is to be painted on both sides. Okay, so I'm just going to draw that. Has a radius of 5 centimeters. Find correct to the nearest centimeter squared the area that is to be painted. So to find the area of this plate, we have to find the area of one side and then multiply by 2 because we're painting both sides of this plate. Okay, that's all we got to do. And you can do that on your own. Question 17. A goat grazing in a rectangular field is tied to a corner post P by a rope of length 7 meters squared. Find the area which the goat cannot graze. So we have to find the area of this shaded region here. Right. Now, to find the area of the shaded region, I'm going to find the area of this rectangle, the whole amount there. That'll be 9 times 10. Oh, sorry, not 9 times 10. Almost made a mistake there. This is 10. Now, we need to find the radius here. This is this length here, which is also the radius of this quarter circle. Let me see. There is by a rope of length. Alright, it tells you the length of the rope, which happens to also be the radius. So the length of this rope is 7 meters. So that means this is 7 meters. Whoops. This is 7 meters. Alright, so that means the total length of this rectangle. The total length of this rectangle is 7 plus 9, which is 16. So this will be 16. 10 times 16 is 160. So the area of this rectangle, the whole thing, is 160. Now we're going to minus the area of this quarter circle. The radius is 7. So the area of this quarter circle area is equal to let me see, I'm going to be pi times r squared divided by 4. Pi times r squared, which is 7 squared, divided by 4. And then, so what we get, we're going to get 49 pi on 4. So to find the area of the shaded region, area of shaded, we do 160 take away 49 pi on 4. Use a calculator to get the let me see, find it in which cannot be grazed. Okay, yeah, to find it maybe to the closest I don't know, meter squared, and get the answer there. Question 18. Find the length of the radius of a circle whose circumference is 18 pi. Okay, the radius. So we know that circumference equals to diameter. Well, we can say 2 pi r. So 2 times radius times pi, and that's equal to 18 pi. Okay, it tells us the circumference is 18 pi. Alright, so to get radius, we just divide both sides by 2 pi. Divided by 2 pi. And that will cancel out that one, and you're left with the radius is equal to 18. So 18 divided by 2, you can get, this will be 9. Pi divided by pi is just 1, so that's just 9. Radius is equals to 9. Now the area is equal to 49 pi centimeters squared. So the area of a circle is equal to pi times radius squared, and the answer is equal to 49 pi. It's given to us. So what we're gonna do is let me get rid of this. So we're gonna to get to radius. Let's get to radius squared first. So let's divide both sides by pi, and that will cancel out. That will cancel out. So you have radius squared is equal to 49. So therefore radius is equal to the square root of 49, which will give me 7. So the answer here should be 7 centimeters. Alright. Question 19. Find the exact circumference of a circle whose area is 16 pi centimeters. See, now they're asking to find the exact circumference. And they give us the area. Okay, so given the area, let me just get rid of some of this. Okay. So the area A equals to pi times r squared, which is equal to 16 pi. Whoops. Alright, so let's divide both sides by pi, just like what we did before. We can cross this out. So r squared is equal to 16, so therefore r is equal to the square root of 16, which gives me 4. So we found the radius is 4. Okay, we need to find the radius in order to find the circumference of this circle. So if the radius is 4, then diameter must be double of 4, which is 8. Okay, now circumference is equal to diameter times pi, which means 8 times pi. So circumference is 8 pi, and there's your exact value. The answer is 8, so I'll put it over here, 8 pi. They want the exact circumference, so that's the actual answer. Okay, find the exact area of a circle whose circumference is 10 pi. Okay, so circumference is equal to 10 pi. Oops, let me just do this real quick. Equals to, I'm going to say diameter times pi. And that's equal to 10 pi. So circumference is 10 pi. That's that one there. So let's say we divide both sides by pi, and we're going to get diameter is equal to 10. So which means radius is equal to half of 10, which is 5. Now if once we find the radius, we can find the exact area. Okay, so the area, I'm going to write it up here. Area is equal to pi r squared, which means pi times, what's r? We found the radius to be 5 squared, so that's equal to 25 times pi. There's your exact area. There you go. Alright, question 20. I'm going to have to remove some of this, so this working out must go. Okay. For each cylinder, find the volume correct to the nearest centimeter squared. So volume, whoops, is equal to pi r squared times the height. We're given the r, we're given the height, so just plug it into the formula. Volume is equal to pi times r squared, which is 4 squared, times it by the height, which is times it by 7. And that's going to give you, let's leave pi by itself, let's not multiply it. Let's find out what, so 4 squared, which is 16, 16 times 7 will give me 112. So the volume, the exact volume will be 112 pi. And then use a calculator to get the decimal equivalence. Okay, next one. Same thing. Volume is equal to pi r squared times height. So that equals to pi times r squared, which is r is this one, which is 5 squared, times it by the height, which is this one, times it by 13. So r squared is 25, 25 times 13 times pi is equal to your volume. So volume is 25 times 13, So the volume is equal to 325 times pi. Multiply it with pi and get the answer to the nearest centimeter squared. These are all in centimeters, so the answer will also be in centimeters squared. Okay, I'll do the second one. And this one is going to be 1021.01, which is just the same as 1021 centimeters squared. Now to find the second part, find the capacity in liters. Alright, so to find the capacity in liters, we just convert this into milliliters. Remember that 1 centimeter squared is equal to, cubes. This is all centimeters cubed, not squared. This is volume. Remember, 1 centimeter cube is equal to 1 milliliter. So this amount is going to be equal to 1021 milliliters, and then convert it to liters by dividing it by 1,000, and that's going to be 1.021 liters. There you go. There's your two answers. Okay, and do the same thing for the part A as well. Alright, last page. Let's see. Oh, so we have to find. Okay, so we continue on with the previous question. You're asked to find the volume in centimeters cubed, and you're asked to find the capacity by converting this into milliliters and then converting it into liters. You can do that on your own. These are the same, so C and D, they're just cylinders, very simple. Now question C, oh actually, no, this is a different question. This is for, okay. Question 21, find the total volume of each figure correct to 1 decimal place. To find the volume of this shape, we're going to find the area of this semicircle and then multiply it by 40. Or we can find the volume of the entire cylinder and then divide it by 2. You can do both ways. I'm going to find the area of this semicircle, which is a cross-section area. This is called the cross-section area. And now we're going to find the area of this. So let me see. The diameter is 22, which means the radius is half of diameter, which means the radius must be 11. So the area is equal to let me see, pi r squared, but we divided by 2 because it's half a circle. So that's equal to pi times radius, which is 11 squared divided by 2. 11 squared is 121, so the area is equal to 121 pi over 2. Alright, to find the volume, now this is called the cross-section area. Okay, the volume is equal to the cross-section area times it by 40 in this case, times it by the height. So that's going to be 121 pi over 2 times it by 40 over 1. Now I can simplify this. Okay, I can cross this out, this will be 1, this will be 20. So really the volume is going to be equal to 121 pi times 20. Now 100, and the answer is going to be volume is equal to 2420 pi. That's your answer there. Now this is the exact one. They want it into 1 decimal place. So find, use a calculator to get the answer in 1 decimal place. I'm going to put it up here. Okay. Next one, I'm going to find the cross-section area, the area of this shaded region here, and multiply it by 11. Okay. So to find the area of the cross-section area, we find the area of the big circle. You can do that. Find the area of the small circle and do subtraction. So the cross-section area is equal to area of the big circle, take away area of the small circle, and then the volume is going to equal to the cross-section area times 11. Okay, or you can find the area of the, okay, another way you can do it is you find the volume of the entire big cylinder, and then you find the volume of the small cylinder and you do a subtraction, and that'll give you the volume of this solid. Alright, next question. To find the volume of this shape, I'm going to find the area of this cross-section area. This is the cross-section area. And then I'm going to multiply it downwards by 2. So the cross-section area is equal to, now this is a quarter circle. How do I know it's a quarter circle? Because this is a 90 degrees. 90 over 360 is 1 over 4, 1/4. Alright, so what we're going to do is we're going to find that we have the radius, which is 8.1, so the cross-section area is going to equal to pi r squared divided by 4, quarter circle. So that's equal to pi times r squared, which is 8.1 squared, divided by 4. Let me just do that real quick. So that's going to equal to 65.61 times pi divided by 4. And if we divide this by 4, we're going to get 16.4025 times pi. And we're going to multiply that by pi, and you're going to get 51.5299735, and so on. And then what we're going to do is multiply to find the volume. Volume is equal to the cross-section area times it by the height. So that's equal to 51.53 times it by 2. Just multiply it by 2, and you're going to get 103.06. Does it say to the nearest anything? 1 decimal place. Okay, so that's just equal to 103 centimeters cubed. Done. Okay, question D. Now this one, we're going to find the area of this cross-section area here. That's the cross-section area. So the cross-section area, then we multiply it by 17. Okay, so the cross-section area is really, what fraction of a circle is this? This you can see it is 3/4. Okay, because this is 90 degrees, so 90. So this must be 270 degrees. 360 minus 90 is equal to 270, and 270 over 360. That's gonna be divided by 9. You get 3 over 4, 3/4. Okay, so I need to find 3/4 of a circle. So I do 3/4 times pi times r squared, which is 5 squared. R is the radius, which is 5. Alright, now we're gonna have, let me see, this will be 3 times, this will be 25. 3 times 25 will be 75, so 75 pi on 4. There's your cross-section area. Now to find the volume, we must do 75 pi on 4 and multiply by 17. So that amount there. Okay, so 17. Now this is 17 times 75, and then divided by 4. You're gonna get 318.75 pi. I left it in pi form, and that's the volume. So let's multiply that with pi to get our answer, which is equal to 1001.38. It says to the nearest 1 decimal place, so that's equal to 1001.4 centimeters cubed. So that's the volume. Okay. Alright, that's the answer for that one. Now let me just rub out some of this. I need some space. And let's move all of this up. Oops. Actually, I'll shrink it. There you go. Alright, now it says find the total perimeter of each figure correct to 1 decimal place. Perimeter, okay. We're gonna find the perimeter of this shape, so we need to find this part of a circle. Now, we need to know what fraction of the whole circle this circumference represents. This circumference part, this arc, sorry, not circumference, the arc represents. Now, let's find the circumference of the entire circle. Okay, so circumference of the entire circle is equal to diameter times pi, which equals to, now the radius is 7.3, diameter must be double of that, would be 14.6. Okay, so 14.6 times pi, that's the circumference of the entire circle. But we only have a fraction of the whole circle, so let's find out what fraction it is. So we do the angle, which is 120 degrees, over the entire circle will be 360 degrees. Cross that out, you get 12 over 36. Divide top and bottom by 12, you get 1 over 3. So this is only 1/3 of the circle. So to find this piece, this will be circumference of this arc, or length of this arc, is equal to 1/3 times the circumference of the circle, which is 14.6 pi. So let me just do 14.6 divided by 3. Oh, that's not a very nice number. I'll just actually get the answer. So 14 times pi divided by 3, you're gonna get, the arc is gonna be 14.66. Okay, to two decimal place. So now we want to add, so that's that one there. Alright, this will be in millimeters. Now to find the perimeter of this, we have to add another 7.3 and 7.3. So it'll be 14.66 plus 7.3 plus 7.3. And the answer is 29.26. Oh, to 1 decimal place, sorry, so 29.3. There you go. Now you can do the same thing for this one as well, but this is 72 degrees, so let me see. 72 degrees over 360 will be 1 over 5. Yes, alright. So this is 1/5 of a circle, okay? You can do the rest. So find the circumference of the whole circle and then divide it by 5 to get this arc. This arc is equal to the whole circle pi r squared divided by 5. And then you're going to add 23.5 and another 23.5. By the way, the radius is equal to 23.5. You can plug it into there, get the arc. Question 23. Find the total area of each figure. Okay. So 135 degrees over 360. Let's see what fraction of a circle we got. And this is going to be 3 over 8. 3/8 of the entire circle. So to find the area of this sector, okay, is equal to area of the entire circle, which is pi times radius squared. Radius is 5.1 squared. Then we must multiply that by 3/8. Okay, and then you get your answer there. Now let's find out what fraction of a circle this is. So 110, so 360 take away 110, and that'll give me 250, I believe. So this angle is 250. So 250 over 360. See what fraction of the circle this is. So you get 25 over 36. Can we simplify this? No, we can't. So just leave it like this. So to find the area of this sector, of this major sector, we do the area of the entire circle, which is pi times radius squared. Radius is 4.3 squared over 1, and we multiply by 25 over 36, and then you get the answer. Alright,